Hey everybody, this is Dell Latitude 3510. This was listed on a secondhand website as being faulty. When I contacted the seller, he said that he brought it to a computer repair store. They said there was a fault on the motherboard and it would cost 80 euros to repair. He decided not to repair and listed it for 120 euros, and that's how much I paid him for it. So let's see what the fault is. I have it plugged in here. I'm just going to press the power button. Okay, we're getting nothing at all. I'm going to take the motherboard out and we're going to take it to the screen.
And this is what the motherboard looks like. Now I can confirm that my power adapter is good, and I can confirm that when I plug my power adapter into this board, the LED stays on. We may have seen before that when a laptop motherboard is shorted and you plug in the adapter, that the LED goes off on the power adapter, but that's not the case here. So what I'm going to do is I'm going to start at the DC in jack. I'm going to plug in my power adapter and I'm going to start taking voltage measurements on the input. This is where our DC power jack connects to the board, and as you can see we have 8 pins on this. I'm going to mark in those pins right here. From our schematic we can see the pins 6, 7 and 8 are our DC in. So what we can do to confirm that there's no issue with our DC power jack is to measure at pins 6, 7 and 8 and verify that we have our 19.5 volts. My multimeter in volts DC in the 20 volt range. I place my black probe to ground and I place my red probe to either pin 6, 7 or 8. They're all connected together anyway, so I place it to pin 7 and I find that we have 19.94 volts. So that means that our DC power adapter is good and our DC power jack is also good. So back to our schematic. We've confirmed that on pin 6, 7 and 8 we have 19.94 volts here. So where does it go from here? Well, what our schematic tells us is it comes across here through 2 parallel inductors and then onto the 3 source pins of a MOSFET. As you can see on the actual motherboard itself, we don't have those 2 inductors. Our 19.94 volts is coming straight down from pins 6, 7 and 8 across this track and onto this first MOSFET. So let's get a look and see what this MOSFET is. Now this MOSFET is an SM3307, which is a P-channel enhancement mode MOSFET. And if we look at the pin configuration of this, pins 1, 2 and 3 are source pins, pin 4 is a gate, and pins 5, 6, 7 and 8 are drain pins. So let's mark them in our MOSFET. Now we know that we have 19.94 volts here, which comes onto the 3 source pins of this MOSFET. So the question is this MOSFET switching on and permitting our 19.94 volts through from our source to our drain pins? This obviously is controlled by the gate pin, so the gate pin should be low in order for this MOSFET to be turned on. So I'm going to check what the voltage is on the gate pin. Measuring at the gate pin of that MOSFET, we find there's 3.24 volts, so that should be an appropriate voltage to turn this MOSFET on. And measuring at the drain pins of the first MOSFET, we confirm that there is 19.94 volts here. Back to our schematic, we have confirmed that we have 19.94 volts at this point. So where does it go next? Well, next it comes on to the drain pins of S2, which is the second MOSFET, which is this MOSFET right here. And as you can see, it's also an SM3307. So we have 19.94 volts on the drain pins here. So we need to check and see if we have 19.94 volts on the output. And to make this easier, I'm also going to mark out the pins on that second MOSFET. And once again, with my multimeter in volts DC in a 20 volt range, I want to take a measurement at the gate pin of that second MOSFET. So I place my black probe to ground up here, and I place my red probe to the gate pin, and I measure 19.20 volts. And measuring at the source pins of the second MOSFET, I find that it measures 19.34 volts. So what do we think of that? Well, that doesn't look right to me. As we saw from the first MOSFET, which is an SM3307, we have 19.94 volts on the source, we have 3.2 volts on the gate, and we're getting a full 19.94 volts on our drain. So that's fully switched on. We're getting 19.94 volts on the drain pins of the second MOSFET, which is also an SM3307. We're getting 19.20 volts on the gate, and we're only getting 19.34 volts on the source. So I don't think that this is being switched on fully. The gate on this is being kept high for a reason. Now, before going any further, I wanted to try and confirm that there was no obvious issue with that MOSFET itself. So I switched my multimeter into diode mode, and from drain to source I measured 0.54, which is okay. I also confirmed that there was no short from gate to drain and no short from gate to source. So the MOSFET itself seems like it's okay. The battery management IC that's in use on this laptop is the ISL9538C, which is a buck boost narrow output voltage DC or NVDC charger. So even though we have a full schematic for this laptop, I prefer to work with the typical application circuit of these battery management ICs because they tend to lay it out on one A4 sheet where you've got all of the important pins that can be identified, and it gives you an overview of how the circuit works and where we can check for voltages and check for shorts. So as you can see here, we have our input. So I'm measuring 19.94 volts here, which is good. After the first MOSFET, I'm measuring 19.94 volts, and our gate voltage is about 3 volts, so that's also good. However, after the second MOSFET, I'm only measuring 19.34 volts here, and I'm measuring 19.2 volts on the gate, which is too high. Now, as you can see, that gate signal is being provided by the ISL 9538. So what I want to do is I want to check and see what output is this giving us. We've only got 19.34 coming in here, so I don't think we're going to have an appropriate output voltage. And this VSYS or VSYS is essentially our main power rail. So let's check on that and see what the voltage is on it. I need to locate where these components are so I can identify where to measure VSYS. So we have identified this as our second MOSFET, which is essentially here on the circuit. So we need to find the current sense resistor, which is the next component in line. Now, it's not on this side of the board. What I have after the second MOSFET is there are a number of via underneath this RAM chip here. So it's going through to the other side of the board. So let's follow it through. Voltage comes through at this point here, and we follow this along this track till we eventually find our current sense resistor. So that current sense resistor corresponds to this current sense resistor here, and then after that, that comes down onto the high side MOSFET of a high side low side MOSFET configuration, and that is this MOSFET right here. The source of the high side MOSFET Q1 and the drain of the low side MOSFET Q2 are joined together, and the source of the low side MOSFET here is connected to ground, so let's mark that in as well. The next component in line is this inductor L1 right here, which is actually physically on the other side of the board, so I'm going to represent it here with a symbol. Our inductor connects to this point right here, which is the drain of Q3 and the source of Q4. So let's mark that in. We can also mark that Q3 is connected to ground, and that means that the drain pin of Q4 is VSYS. So this is our main power rail right here, and this is where we need to measure. And with my multimeter in volts DC in the 20 volt range, I place my black probe to ground and my red probe to where VSYS is, and I find that it measures 0 volts. So we're getting no main power rail at all. So with the power off, I decided it might be a good idea just to check the main power rail and see if we had a short. So I placed my red probe to ground, my black probe to VSYS, and what I measured was 0.000. So it looks like the main power rail is shorted. So when we have a shorted main power rail, or any short at all, what do? We're going straight to voltage injection. And just to show how I set up my voltage injection, we introduce our DC power supply, connect my black wire to ground. We've already established that that's the ground side of the lower side MOSFET. We connect our red wire to where we were detecting the short on the VSYS rail, and I set my voltage to 1 volt with a current limit of 500 milliamps to start with. And this is how I have that set up in the real world. So black wire to ground and red wire to our main power rail, and I've just got a couple of crocodile clips connected to that. So my voltage is set to 1 volt. I've set my current limit to 500 milliamps, and I'm going to plug this in now.
Okay, so what do we got? Okay, well the limit is already hit, so our voltage is pulled down to 0.2 volts. So we've got a dead short. So I'm going to start touching around the board, see if I can see anything heating up with just 500 milliamps going through it.
Now when I increased the injected current to the full 5 amps that my DC power supply can provide, the area around these two capacitors started to warm up, but only very slightly. Just for full disclosure, I did notice this capacitor was damaged during the visual inspection. However, I thought it would be more beneficial for the learning process to work through it as if we had no tells as to which components were blown. Even now I still don't know if it's just the one or the two components, but I did spot this at the start. So what I'm going to do now is I'm going to remove these capacitors one by one and see if that removes the short completely. So with my hot air gun, I set about removing the first one. Now to my surprise, when I removed that capacitor, there was actually still a short on the board, so I decided to take off the other one as well. And now with both capacitors removed, I decided to do a continuity check again just to see if the short is still there. And this time, the short is gone. So just to confirm, that was actually the shorted cap, not the one that was explosively blown. I actually had another one of these motherboards, the exact same motherboard, that came in with a spill of curry on it, don't ask. So I was able to just take the two capacitors from this and use them. And just in case anybody else needs to replace those capacitors, they're actually a 10 microfarad capacitor.
Okay, the moment of truth. Okay, at least we got a light this time anyway. We had no light at all the last time. And we have our Dell logo. Excellent. Now I did pay 120 for this, so I do need to realize some money back. I wonder how much is it worth secondhand. Post in the comments below if you know. That's my video for this week, guys. Hope you all enjoyed it. Please post down in the comments below if you have anything to say, any suggestions or any comments or any feedback at all. I'll be back with something else next week. Thanks.